Today's lesson will be over permutations and combinations. However, first I want to go over what we learned yesterday. So, at our station yesterday, we learned about the fundamental counting principle. And the fundamental counting principle is what occurs when you have more than one event. So, let's say that I have two events. I have event M and event N. And so these are two different things that are occurring. It might be two dice rolling together, and it might be maybe a dice and a coin, or maybe it's me selecting a card, or there's all these different events that it could be. So it's any event that would occur that would give me a probability. And the fundamental counting principle says that if I want to know the total number of different ways that these two events could occur together, then I'm going to have to multiply them together. So if event M, say, has 6 outcomes and event N had 3 outcomes, then the different ways that these events could occur together are 6 times 3, or M times N. We also learned about factorial. Factorial is when you have an integer and it's multiplied by all previous integers down to 1. So it's an integer multiplied by all previous integers. And first off, before we start doing these, make sure that you know what an integer is. So an integer is a whole number which is positive and greater than 0. So the first integer is going to be 1, and then we have 2, 3, so on and so forth, all the way up until positive infinity. So there are those positive whole numbers. So what does a factorial look like? Well, you have our example here. And if we take 5 factorial, then it is 5 times 4 times 3 times 2 times 1, and that'll give me 120. So our actual objective today is to distinguish between permutations and combinations. And permutations and combinations are just when we're selecting objects. And there's really two main distinctions here, is that a permutation is going to be an ordering of objects in which the order is important, and a combination is going to be an ordering of objects when the order is not important. So a permutation is kind of like when you are looking for a seat in a classroom and you're trying to sit next to your friend, right? Or actually a better example is when we're looking at a choir or a band. You have your chairs, right? The first chair is the most important, the second chair is the second best player, etc., etc. So the order which you're seated is actually very important to you. Versus a combination might be something along the lines of, say, you've entered a drawing and you want to see if you're going to win, and there are 10,000 people and there are only 10 winners. It doesn't matter to you when your name gets drawn, but you do want to know what the probability is that you're going to get drawn from the bag. All right, so here under permutation, we can write that definition is an ordering of objects in which the order is important. And a combination is going to be an ordering of objects in which the order is not important. And remember, this is not going to give you a probability just yet. It's just going to give you total numbers of ways that something can happen. A good example of this is when you're trying to have your runners, right? So if we're talking about a permutation, we're going to talk about the order that runners finish a race, digits to the phone number, a code, or ID. So our example here for a permutation is the order that a runner finishes a race. So order finishes a race. And then for combinations, it's going to be things like members chosen for a club, or playing the lottery, or selecting colors to color with. Another way to think about combinations and permutations is like when we were talking about chairs yesterday. So just remember, we were talking about 3 people filling 3 chairs. So a permutation or a combination typically occurs when you have more people than you have chairs. So let's say that I care about the order which I seat people in 3 chairs, and I have 6 people to fill the chairs. So the rule is that these 6 people need to fill these 3 chairs in some order. And I don't care what the order is, I just want to know the total number of ways that they could fill the chairs. So the rule is that they are n objects taken r at a time. And what this looks like as far as our notation will go is that we have n, which is like my number of people that I'm choosing from. We have my p, which denotes that this is a permutation. And then we have r, and r represents that number of chairs. So those are the slots that I'm filling, is the r, and the n is the number of people that I'm choosing from. The same thing will occur for combinations. So again, we're talking about 6 people trying to fill 3 chairs. And the rule here is that you have n objects taken r at a time as well. And so again, we'll have an n, then we'll have a c, and we'll have an r. So we're taking the combination of n number of people and putting them into r number of chairs. So the actual formula for each of these, for permutations, we're going to say that it is n factorial divided by n minus r factorial. And down here for our combinations, it's going to be n factorial divided by r factorial times n minus r factorial. All right, so our assignment today is we're going to work on this card sort. So make sure that you and your table partner have the cards, and you're going to categorize each of the cards into the appropriate category. So you will have combinations and permutations, and you're trying to sort these sets of cards into the 2. Now tomorrow we're going to actually calculate some probabilities and some permutations and combinations using these situations. All right, so until tomorrow, have a good day.